Hi everyone, welcome back to Science Sketchbook. In this brief video, I'm going to explain the difference between stereo and regioselectivity as they pertain to addition reactions. Let me clear those up for you. So, for some context, the basic idea of an addition reaction is that it adds atoms along a pi bond. Notice in this example, you started with a double bond and then you added the two halogens shown. The question is, how did I know that one should be wedged and the other should be dashed? How did I know which halogen went on which side of the double bond? Well, that's where the reaction selectivity comes in. Stereoselectivity is where the spatial position of the atoms are important during the reaction. Essentially, this can tell us if we add atoms to the same side, like two wedges or two dashes, or to different sides, like one wedge, one dash. Let's look at this example. This alkene can react with osmium tetroxide in sodium bisulfate and water. This is a dihydroxylation reaction, meaning we will add two hydroxy groups or two OHs to this double bond. So look, here is the product, and it seems that both of the OHs went on the same side. They're both dashed here. Of course, they have the option of both being wedged as well. That's why I have plus enantiomer there. So let's see the stereoselectivity. A syn addition can be kind of viewed as a cis addition of atoms, where they add to the same side. An anti-addition is kind of like a trans addition, where the atoms add on opposite sides. Both of these can occur for various reasons, depending on the transition state and overall mechanism of the reaction. So, just based on what I showed you, would you say this is a syn or an anti-addition of OHs? Yeah, syn. They are indeed on the same side. Alrighty, now regioselectivity is when the atoms add to a specific location on the double bond, or region of the double bond. Will an atom bond where there is more substituents? So we're going to use the same substrate, but we're going to react it with HCl, or hydrochloric acid. And well, the product shows that you add the chlorine to the more substituted side, or the side with more stuff coming off of it, and the hydrogen to the less substituted side. By the way, I just drew them all flat here because this particular reaction isn't even stereoselective. Thus, it'll form all the products with both wedged or dashed or mixed, etc. That would just kind of look like a mess here. But the main focus here is that the chlorine specifically got this region of the double bond. So let's see what the regioselectivity is called. A reaction is Markovnikov if the priority atom gets the more substituted side of the double bond. That would be the more stable side, essentially the good side of the double bond. Now, this priority is often something like OH, like if you had water present, an alkoxide group, for example, a carbon and oxygen added on from an alcohol, or a more electronegative atom. For example, if it was chlorine versus bromine, chlorine would win the priority and get the more substituted side. Keep in mind, in general, OH tends to be a pretty high priority, even over electronegativity. So it just really likes to add to the good, stable side, so just keep that in mind going forward. So, of course, the anti-Markovnikov addition is the opposite. It is less common, but occasionally, the priority will go on the less substituted, less stable side of the double bond, essentially the bad side. So which term suits the reaction shown? Yeah, it is Markovnikov because chlorine is definitely prioritized over hydrogen for that good, stable seat. Again, the reason for it can be seen in the mechanism for each reaction. I'll explain those features when I show you the mechanism for each reaction in separate videos later on. So to just quickly finish up here, these are some examples of common stereoselective reactions in Organic Chemistry 1. Halogenation and its similar reaction of a halohydrin formation both do an anti- or trans-looking addition. The hydroborations do syn additions. Dihydroxylation also does a syn addition. Common regioselective reactions in Organic Chem 1 include some of these. The hydroborations do anti-Markovnikov reactions, not to be confused with anti as in the stereoselectivity. So those are anti-Markovnikov. And perhaps later on in your course, you'll see radical halogenation too. All of these others are Markovnikov additions. Thus, in these situations, you would add your priority to the more stable side of the double bond. Alrighty, so pretty brief concept overview here as you prepare to get into addition reactions. So feel free to reference this video if you're confused anywhere. But otherwise, that is it for now. See you in the next page. Bye.